Okay, last day of review on motion graphs before we take our quiz tomorrow. So let's just go ahead and get started. Starting kind of the reverse of what we did yesterday. So yesterday we had a table or a graph and we made a table. Today we have a table, we're going to make a graph. So I'm just going to go through and plot the points that we have here. So I have 0, 0, 1, 2, 2, 4, 3, 6, and then I have 4, 6, 5, 6, 6, 6, and I have 7, 7, 8, 8, 9, 9, 10, 10. Okay, and I'm just going to connect these with a line. It's pretty clear that we have 3 different segments, which indicate 3 different movements. Okay, and I'm just going to go ahead and label them A, B, and C. Okay. Great. And we're going to be getting the rate of these 3 different segments. That's what we're being asked to do. So just a quick review here from a graph. If we're trying to find the rate, we're looking at the rise or fall divided by the run. And if we're getting the rate from a table, we're looking at the change in y divided by the change in x. Okay. All right, so the first rate we're being asked about is from 0 to 3 seconds. Okay, so from 0 to 3 seconds, if I were looking at the table, I would say to myself, okay, 0 to 6, what's the change? The change is plus 6. 0 to 3, what's the change? The change is plus 3. If I were more of a visual person and I wanted to use the graph, I would draw my slope triangle in and I would find the measurements of both sides. So 1, 2, 3, 4, 5, 6, I'm rising 6, running 1, 2, 3, running 3. Okay, so you can see the connection between the data in the table, the data in the graph. We get the same numerator and denominator for our rate. So I just need to calculate that. 6 over 3, our rate is 2 feet per second. And we're asked to describe what that line or what that graph looks like. So it's a line, I kind of just said that. So it's an increasing line, and it's relatively steep, I would say. So let's say it's an increasing steep line. Okay. All right, next interval we're looking at is 3 to 6 seconds. Okay, so from 3 to 6 seconds in the table, I'm looking at the change from 6 to 6. The change is 0 because 6 plus 0 is 6. And then from 3 to 6, the change is 3. Kind of hard to draw a slope triangle when we have a horizontal line. But we can think about it along the lines of, well, you're rising 0 and you're running 3. So 0 over 3, that's the same values that we got out of the table, which gives us 0 feet per second as a rate. Okay, and then what does the graph look like? Well, it's a horizontal line. Okay, and we know that that means the object is stopped, which means the speed is 0. Right. The last one that we're looking between 6 and 10 seconds. Okay, so what is the change from 6 to 10? The change is plus 4, and that's on both sides. If I was looking at the graph, I would draw my slope triangle in and count my blocks. So 1, 2, 3, 4, so plus 4, running 4, 4 over 4 gives me a rate of 1 foot per second. Okay. And we're done. We're not asked to describe that part of the graph, so we can move on. All right, the next part that we're looking at here, we have a motion graph that's showing motion relative to a motion detector. Okay, so movement relative to the motion detector. And Tamara and Robert, they are going to describe how they should be moving to create this same graph. Okay, so the first thing, where should Robert begin his movement? So remember, our starting location is always on the y-axis. Okay, so starting location is 24 feet is our measurement from motion detector. How should Robert move for the first 2 seconds? Okay, when we're talking about movement, we need to make sure that we address speed and direction. Okay, so for this part right here, for the first 2 seconds, this line right here, how would we have to walk for that line to be created by the motion detector? Okay, so let's talk about speed. It's a line, so the speed has to be constant, and it's steep, so it's quick. We're walking at a quick, constant pace. So speed is taken care of. We need to talk about direction. The line is decreasing. That means that the distance between you and the motion detector is decreasing, which means you're getting closer, so you're moving towards. Okay. All right. Part C, what should Robert do between 2 and 3 seconds? Well, horizontal line. Horizontal line means stop. You're not moving. What about 3 to 4 seconds? Okay, it's a line. So let's talk about speed. Speed is constant. It's relatively steep, so quick, constant pace. The line is increasing though. So if it's increasing, the distance between the person and the motion detector is increasing. So you're walking away. Okay. How fast should Robert walk between 4 and 6 seconds? So I'm just going to go ahead and draw my slope triangle in here so that I can trace my rise and my run. Something that is important, if you'll notice on our y-axis, we are not counting by ones. We're counting by fours. So each block counts for 4 feet. So we need to think about that when we're counting our fall. So our fall is not 1, 2, 3. Our fall is 4, 8, 12. So we're falling 12 and running 1, 2 because our x-axis is counting by ones. Okay, so negative 12 divided by 1. The speed is negative, or the rate is negative 12 feet per second. How fast should Robert walk between 6 and 7 seconds? So I'm going to draw my slope triangle in again. Oh, that's not the right way. Yep. Keeping in mind that each block is 4, so I'm rising 4, running 1. So my rate is 4 feet per second. Okay. All right, last question. When should Robert move most quickly and why? Okay, so if you are asked this question, you can answer it without calculating the rate. Now, we're asked to calculate the rate for this question, so we will have to do that eventually. But if you are not told specifically to calculate the rate, then you don't have to. So I'm looking at this, I'm just looking at the graph. And if I look at the graph, I should be able to tell where Robert is moving most quickly by looking at the steepness of each part. And to me, it's pretty clear that from 0 to 2 seconds, that orange piece of the graph is the steepest line on the graph. So 0 to 2 seconds. And I can say because it's the steepest line. Okay. But of course, then we're asked to go ahead and find that rate, so we need to find the rate. I'm going to draw in my slope triangle. And I'm falling 4, 8, 12, 16, 20. So I'm falling 20, running 2. So negative 20 divided by, negative 20 divided by 2. Sorry, my dog is going a little nuts, is negative 10 feet per second. And we're done.